Welcome back, students. We will be looking at section 2.3, practice problems for more on solving linear equations. So let's go ahead and get started. Number one, we have 4x plus 2 equals x minus 6. I'm going to move my 2 first. I'm going to subtract 2 from both sides. I get 4x plus 0 equals x minus 8. Rewrite that without the 0. Now I notice I need to move this single x to the side with the 4x. So I get 3x equals 0 minus 8. Rewrite that. Okay, divide that by 3. Divide that by 3, and I end up with, I'm going to write my answer over here, x equals negative 8/3. Not a very pretty answer to start off. It's a fraction, but you can have fractions as the answer. It's not probably going to be common in your homework problems, so if you do end up with a fraction, double check your work, make sure you didn't make an error, but sometimes you will have a fraction, so if you've done all the steps correctly, then that's probably your answer. One way to verify it though is to plug it back in and check it, see if it actually works. If it doesn't work, then that's not your answer and you know you have an error somewhere. Okay, so let's look at number 2. I'm going to subtract 6 first. I get 10y plus 0 equals 12y minus 10. Now I'm going to subtract the 12y from both sides to get the y's on the left. I get negative 2y equals 0 minus 10. So negative 2y equals negative 10. I'm going to divide both sides by negative 2. And we get y equals 5. Okay. Number 3. All right, so before I start moving around, remember we have to double check and make sure there's nothing that we need to distribute, combine, simplify down, fractions that we need to get rid of. This one has distributive property that we need to do first on the right side. So don't forget there's that invisible 1 here with that negative sign. So I'm going to distribute that negative 1 to everything in here. So I get 2d plus 1 equals negative 1 times d, it becomes negative 1d. Negative 1 times a 3 becomes a minus 3. So now, can I combine anything? No, there's nothing that we need to combine, no like terms. So I can actually start moving from side to side. I'm going to subtract 1. So I get 2d plus 0 equals negative 1d minus 4. Rewrite that. All right, I'm going to move the negative 1d by adding 1d to both sides. I have 3d. All right, I'm going to bring this up over here just so we have room. So I have 3d equals 4. Oh, nope, negative 4. I made a mistake up here. I put plus when I should have had minus. So let me fix that. Good thing I have my steps written down so I could see that error that I made. Okay, so negative 4. So now I'm going to divide by 3, and I get d equals negative 4/3. So again, it is possible to get fractions. We don't like to get them as answers because it causes us to doubt that we did our work properly, but when you doubt, go back and check. Actually, I would recommend you check your answers every time. It's the best way to find your errors. If we had time in the videos, I would do that, but I don't want our videos to be any longer than they have to be. Okay, so let's look at the next one. I'm going to change color here just so we can differentiate. So we have 5 times 2x, 5 times the 3 here that we need to deal with. So I'm going to have 10x plus 15 minus the 4x that we already have over there, and then 8x plus 27. Combine the 10x and the negative 4x. So I get 6x plus 15 equals 8x plus 27. I'm going to subtract the 15 from both sides. I get 6x plus 0 equals 8x plus not 27. I need to actually subtract that. So I get 12. Okay, so now I'm going to rewrite it. 6x equals 8x plus 12. I need to subtract the 8x. I get negative 2x equals 0 plus 12. And then I get 2x, negative 2x equals 12. Divide by negative 2, divide by negative 2, and so x equals negative 6. Okay. All right, looking at number 5. Distribute on both sides. So I have 8p minus 4 equals negative 6p minus 18. I'm going to add 4 to both sides. I get 8p plus 0 equals negative 6p minus 14. Rewrite that. Now I need to move my negative 6p, so I'm going to add 6p, add 6p. I get, let's see, 14p equals 0 minus 14. Now I'm going to divide both sides by 14, and I get p equals negative 1. Good. All right, number 6. Let's see here. We've got distributive that we need to use on both sides here. Okay, so I have 24 minus 28. Negative 4 times negative 2 is going to give us a plus 8n. 4 times n is 4n. 4 times negative 1 is minus 4. I need to combine the 24 and the negative 28 here, and I get negative 4 plus 8n equals 4n minus 4. All right, I'm going to add 4 to both sides. I get 0 plus 8n equals 4n plus 0. All right, 8n equals 4n. I'm now going to subtract 4n from both sides. So I end up with 4n equals 0 n's, which is just 4n equals 0, because 0 times anything is 0. Now I need to divide both sides by 4, and I get n equals 0, because 0 divided by anything is just 0. And we can have 0 as an answer for a variable. Don't forget that. A lot of times students, when they get a 0, they think they've done something wrong. So, of course, always check your work, plug it back in, see if it works. But it is possible to get a 0. All right, number 7. Distributing again. Okay, so we get 8 times 4 is 32. 8 times the negative c is minus 8c equals negative 8c plus 32. All right, something's going on with this one, I noticed. We've got matching numbers. Looks like matching signs, but let's just keep going just to see. But I'm wondering if we're going to end up with a special case here. Either the infinite or the no solutions, possibly. We might not, but I know that something's going on with this one. All right, so let's subtract 32 from both sides. So I get 0 minus 8c equals negative 8c plus 0. So now I have negative 8c equals negative 8c. So if I add 8c to both sides, I get 0 equals 0. Okay, so we've got infinite number of solutions. So remember, when you get 0 equals 0 and there's no variables left, then you have infinite. That is different though than this up here. Okay, if you have a variable equaling 0, that doesn't mean infinite solutions. That means that variable's value is 0. So make sure you don't get those two confused. So it's only when you have no variables left and you have 0 equals 0 that you have infinite. Right, number 8. Is there anything? Yes, we need to distribute over here on the right-hand side. So we have negative 4h plus 12 equals 3 minus 4h plus 12. Okay, so I have negative 4h plus 12 on this side. 3 plus 12 is going to be 15. So I have negative 4h plus 15. I'm wondering if we're going to have another special case here. Let's see. Let's keep going just to make sure. So minus 12 minus 12. So we have negative 4h plus 0 equals negative 4h plus 3. So negative 4h equals negative 4h plus 3. Okay, so I'm going to add 4h to both sides to get them on the same side. I get 0 equals 0 plus 3, so then I end up with 0 equals 3. Those don't equal. I don't have any variables left, so no, this is going to be no solution. Okay. All right, so again, don't forget to check your work. Okay, it's very important. If I was doing this as homework for myself or a quiz or a test, I'd be checking every one of these answers by substituting back in the original problem and seeing if it is an actual solution. All right, let's look at number 9. We have decimals here. Let's go ahead and multiply those out and then work on getting rid of the decimals if we need to. Okay. So 0.2 times 60 is 12. Zero 0.1 times 60 is 6. Okay, so now let's look at getting rid of our decimals and how we go about that. This is the first time I think we've done one like this. So what I notice is that I have this number here and this number here that's a decimal. I want to count the place values. Okay, so the 0.05, that goes up to the hundredths place. The 0.1 goes up to the tenths place. So the one with the greatest place is what is going to determine what number we need to multiply this whole fraction or this whole problem by to get rid of those decimals. So because we have the hundredth on the 0.05, and that's the furthest right place value, we're actually going to multiply this whole problem by 100. So let me remove these. So I'm going to multiply this whole thing by 100. Okay. So 100 times 12 is 1200. 100 times 0.05 is just 5. So we have plus 5r. 6 times 100 is 600. And then 100 times 0.1r gives us 10r. So now we've gotten rid of all of our decimals and we can just work the problem like we normally would. I'm going to subtract the 1200 from both sides. I end up with 0 plus 5r equals negative 600 plus 10r. Now I'm going to subtract the 10r. Ooh, before I do that, let me rewrite the problem like we normally do. 5r equals negative 600 plus 10r. Okay, now subtract our 10r. I end up with negative 5r equals negative 600. Okay, plus 0. So now I have negative 5r equals negative 600. Divide both sides by negative 5. And end up with r equals 120. Okay, so just remember, when you have a decimal, go ahead and multiply out what you need to multiply out. Then figure out your furthest right place value and multiply everything by that number, so 10 or 100, depending on the place value. Then you're going to distribute that to every item within the brackets, okay? All right, number 10, same situation. Let's go ahead and multiply out, combine everything we need to combine, and then figure out what place value we have so that we know what number to multiply everything by to get rid of those decimals. Okay, so we've got 0.92w plus that 0.98 times 12 is going to give us 11.76. The 0.98 times that negative w, so we got minus 0.98w equals 0.96 times 12 is going to give us 11.52. Okay, so now we've got some items that we need to combine. We have the 0.92w and the 0.98w that we need to combine. So that's going to give us negative 0.06w plus the 11.76 equals 11.52. Okay, so now we can actually look at it and see what place value will determine what we multiply everything by. So it looks like they all have a hundredths place value, which is their furthest right. So that means we're going to multiply everything by 100. So 100, and we have negative 0.06w plus 11.76 equals 11.52. And we're going to multiply that 100 times all three of those items, times everything in there. So 100 times that negative 0.06w will give us a negative 6w. 100 times 11.76 is going to give us 1176. And then we get 1152. So all our decimals are gone. Now I can subtract that 1176 from both sides. I get negative 6w plus 0 equals, let's see, we're going to have a negative 24. So negative 6w equals negative 24. Divide both sides by that negative 6. And w equals 4. All right, now let's look at the ones with fractions. So let's see, is there anything that we can combine? We could combine the 1/5 b with the 2/3 b, but we'd have to get common denominators first to do that. So let's go ahead and get rid of our fractions. I'm going to figure out a common denominator that I need all of them. What would be be a number that they would all share if we were looking for common denominators? 15. 15 would be a number. So what I'm going to do is I'm going to multiply everything by 15 over 1. Okay. So I've got the 15 over 1 out there. I'm going to rewrite the problem. Okay. So I've got, let's see here. 15 times 1/5 is going to be 15 over 5b. 15 times 2 is 30 over 3b, because 1 times 3 is 3. 15 times 2 is going to give us a minus 30. And then we have 15 times negative 2 is going to give us a negative 30 over 5b. None of the denominators changed because we were multiplying all of them by that 1. Okay, so now we still have fractions, but the reason we did this was because now we can actually simplify them. So 15 divided by 5 gives us 3b. 30 divided by 3 gives us 10b. And then we have minus 30. Negative 30 divided by 5 gives us negative 6b. I'm going to combine like terms. 3b minus 10b is going to give us a negative 7b minus 30 equals negative 6b. I need to move my negative 7b over to the side with the negative 6b. So I'm going to add 7b. I get 0 minus 30 equals 1b. So I actually end up with negative 30 equaling b. So not too bad, right? As soon as we got rid of the fractions, it was easy peasy. All right, let's look at this other side over here. So we've got negative 1/4 times y minus 12 plus 1/2 times y plus 2. And then on the other side, we have y plus 4. So again, I'm going to figure out how can I get rid of those fractions? Well, if I multiply both of them by 4 over 1, because 4 is a multiplication answer for 4 and 2, I think I can cancel them all out. So let's do that. So let's say 4 over 1 times, let's see, how do I want to write this? Let's write it like this. Plus 4 over 1 times 1/2. I need to put the y plus 4 in parentheses times 4 over 1. All right, so you'll notice I wrote this one a little bit different. I didn't put the whole thing in brackets. The reason is because in this problem, we only have to multiply it by the numbers outside of each of those parentheses. We don't have to multiply it by what's in the parentheses. So we end up with 4 times negative 1 is a negative 4 over 4. We still have our y minus 12. Then we have 4 times 1 is 4, 1 times 2 is 2. We still have our y plus 2. And then we have 4 times y on this side, which is 4y. And then 4 times 4 is plus 16. Okay, so let's simplify our fractions. This becomes a negative 1 times y minus 12. The 4 over 2 becomes a 2 times y plus 2. And we still have our 4y plus 16. All right, so negative 1 times y is a negative y. Negative 1 times a negative 12 is a plus 12. We end up with 2 times y, which is 2y, and then 2 times 2, which is 4. And we are now in a situation where we don't have fractions anymore and we can combine like terms. So negative y plus 2y, that's going to give us a y, a 1y. 12 plus 4 is 16. Now I can subtract 16 from both sides. I end up with 1y plus 0 equals 4y plus 0. So now I have 1y equals 4y. Bring it up right here so we have a little bit more room. I'm going to subtract 4y from both sides. So I'll see 1y, subtract 4y. I get negative 3y equals 0. Divide by negative 3, because we're not done yet, and y equals 0. So our answer is actually 0 on this one. That one had a few more steps than the previous one, but if you properly get rid of your fractions, a whole lot easier to solve. Okay, so let's scroll up and look at some translating practice. Let me erase this stuff so it's not in the way of what we're about to do. All right, let's look at some translation practice. Write an algebraic expression or algebraic expressions for two numbers with a sum of negative 36. Let one number be represented by x. Okay, so let's see here. We're going to say let first number equal x. Okay, we don't know what our second number is, so we're just going to say let second number equal second number. Okay, so stick with me here. So our first number is going to be represented by x. Our second number is just going to be represented by second number, okay? And they tell us that the sum of these two numbers, so x plus the second number, equals negative 36, okay? Now I told you we're working with an expression, and expressions say we're not going to have an equal sign. Our answer will be an expression. But right now we're trying to figure out what that expression is going to be. So what I need to do is get my x by itself, okay? So, or excuse me, the second number by itself. So I need to get the x on the side with the negative 36. So I'm going to subtract x. And I end up with the second number equaling negative 36 minus x. So the expression that we're actually going to use as our answer is negative 36 minus x. That's how we would end up with our second number that's missing. I know it sounds really odd. This is kind of an odd problem, but you will have one like this in your homework, I believe, possibly the quiz and the test. So I wanted to make sure I went over this really weird problem. All right, number 14. It says, write the answer to the problem as an algebraic expression. A football player gained m yards rushing. So he gained m yards, okay? Gained means added. He got a positive number. On the next down, he gained 14 more yards. So he gained another 14 yards. How many yards did he gain? Okay, so we don't know how many he gained in the first one. We just know that he gained, and it's represented by m, okay? So we have m. Then it says he gained 14 more. So that tells us we're adding 14 to that original amount that he gained. How many yards did he gain? This is how we would represent finding how many yards he gained. It's m, which represents the first value, plus 14 in the second play. All right, number 15. Grace has x quarters. Express the value of the quarters in cents. All right, so let's think this through. She has a certain number of quarters. So let quarters equal x. X represents them, okay? We need to know how much quarters are worth. They're worth 25 cents, okay? So quarters are 0.025, okay? Express the value of the quarters in cents. The problem is we don't know how many quarters. So we need to write an expression that will demonstrate a way to find how much money she has, even though we don't know the number of quarters. So how we would write this is 0.25 x. So the 25 cents times the mysterious number of quarters would give us how much money she has. So this would be our expression. All right, guys, that's the end of this particular practice session. So let's read our Bible verse. Again, the kingdom of heaven is like a merchant in search of fine pearls, who on finding one pearl of great value, went and sold all that he had and bought it. Matthew 13:45 through 46. All right, hope you're having a great day. See you in the next video. Bye.